Hello everyone. Today we're looking at a new pattern to show triangles are congruent, and the pattern is a side angle side pattern. Let's first show why it works before we get to filling in the blanks here. So again, I'm going to this triangle that we've seen before, and I'm going to pull apart the sides so we sort of explode it into all of its parts, and that's how we get things like angle A, or things like just a side, right? So we should get 3 angles and 3 sides. And so we're exploding the triangle, we're pulling it into all of its different components, and we're studying this pattern of side angle side. What that means is we need 2 sides and 1 angle. This is different from the previous pattern, which was a side 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 pattern. We had 3 sides and no angles at all. So again, the question is, can we get, I should say, we're not just asking can we get the same triangle, but is it possible to get any different triangle when we use just this combination of parts? Because if we can get a different triangle, then this pattern does not work to prove that triangles are congruent. We have to get only the original triangle and no other triangle. So here's my angle A. Remember that with an angle, we're just really capturing that spacing between the sides, and the sides of an angle go on forever. So that is clearly a lot bigger than the original triangle. So if we were to then bring in 2 sides, here is side AC. Remember, we have to match up the A with the A. So we're going to line up the A with the A, and then again we have to determine where to put this. Well, if I were to set this segment AC like this, well then we're creating a much bigger angle. We don't want that. We want the same angle. So I'm going to line up segment AC on the ray that is created by angle A. And then I'm going to take the bottom segment, again lining up point A with point A. And I can't put this anywhere I want because again that would change the size of the angle. We have to keep the original angle like so. So we have this angle A creating this spacing between the sides. We have this side and this side. And the question is, am I getting a triangle at all? More specifically, is it a triangle different than the original? So I ask this question to you. I ask it to my students in class, and they say, nope, there's no triangle. Well, actually, yes, there is. There is a triangle, because we studied a long time ago that any 2 points make a line. So even though there is no line drawn here between point B and point C, we can infer that a line can exist right here. What we're saying is that with just this minimum combination of parts, side, side, and the angle between, have we created a vertex A, a vertex B, and a vertex C in such a way that if we connected A with B and B with C and C with A, would we get a triangle that is different than the original? So I'm bringing back in the original triangle now and lining it up, and you can see it's exactly the same size. In other words, we can create a triangle and it is not different than the original. It is exactly the same as the original. That means we can prove that 2 triangles are congruent with this combination of sides. Now let me illustrate, for example, what would happen if we took away all the sides and tried some other pattern. Like, for example, what if we tried angle, angle, angle? So here's angle C, here's angle B, and there's angle A. Well, if I were to try to line these up, because the angle sides go on forever, there's no indication to figure out where point B is supposed to be placed relative to point A, right? Because we don't have that side that would say B must go here and A must go here. If the sides are gone and we just have angles, we could create a triangle something like this. And the question is this different than the original triangle? It sure is different. It's a lot bigger than the original. So what we're looking at is a pattern of 3 angles that don't show 2 triangles are congruent. So we can never use the angle, angle, angle pattern. Previously we studied the side, side, side pattern, That works, but there is no angle, angle, angle pattern. So I'm showing that so that you can see, in contrast to when we use today's pattern of side angle side, notice how when we use this pattern, we always get the original triangle, same size, same shape, every single time. Alright, so that explains why the pattern works. Now let's take a look at our notes and fill in these blanks. So there's two parts to today's lesson. First, we're going to be taking a look at figures with some markings on them, and we need to identify if they in fact show this side angle side pattern or not. And then secondly, we'll take a look at a couple of proofs to show how we are going to mark the diagrams and fill out our two-column proof. So this is a summary of the pattern right here. You can see the markings on the diagram. So here's one pair of congruent sides, here's a second pair of congruent sides, and then here's a pair of congruent angles. But what's most important is that the position of the angle must be in between the two marked sides, and that's what this says right here. If two sides and the included angle, and I'll talk about that in just a moment, and the included angle of one triangle are congruent to two sides and the included angle of the second triangle, then the two triangles as a whole will be congruent. So let's talk about this included angle right there. So when we are saying included, we're really talking about a location. The included angle is between the two marked sides. It is possible to have a non-included angle, and we'll get to that in the next day or two. This one happens to be the included angle, so the included angle is between the two marked sides, while a non-included angle is not between the two marked sides. So for example, angle W would be a non-included angle because it is not between the two marked sides. Angle V is also a non-included angle. Only angle U is an included angle, so it's between. You can think of it as touching the two marked sides. Alright, so spelling it out here, segment RS is congruent with segment UV. Angle R is congruent with angle U. And segment RT is congruent with segment UW. And with that combination of parts, we can then write our congruence statement. Remember, a congruent statement is stating the names of the figures. So triangle RST is congruent with triangle UVW. Alright, so that's the pattern we're looking at. So the first thing we want to do is just practice identifying an included angle. And we're going to do that with example 1. Use the diagram to name the included angle between the given pair of sides. See if you can find these. So segment GH and segment HI. Can you identify which angle is the included angle? Here's one technique you can use. You can use your pens or pencils just to kind of line them up with that side. So here's my marker set up so it's along this segment GH. Here's another marker set up so that it's along HI. And then just look to see where are the markers touching. That's the included angle right there where the markers touch. Or say you're taking a quiz, you don't have two pencils, just use your fingers, right? So put one finger along one segment, put one finger along another segment, and where they touch, that's your included angle. So angle H is what we want. Remember, with naming angles, you can name angles with a single letter if there's only one angle to be found there, or you can use a 3-letter combination, call that angle GHI, and name that forwards or backwards, angle IHG. Alright, so there are 3 ways to name that particular angle H. Try another one. Here's segment HI and segment IG. Can you identify and correctly name that included angle? So again, you take your marker, here's segment HI, here's segment IG, and where they touch is right here, so the included angle is going to be right in here. That's the included angle we're looking at. What that means is we have a vertex at I, but I have lots of angles with a vertex at I. I don't want this angle. I don't want the big angle. I want this little one here. So we can't use a single letter. We have to use a three-letter combination to name this angle. So we could call it angle HIG, or the other way around, angle GIH. And the last one, here we have segment GI and segment IJ. Can you find the included angle? Again, we want a three-letter combination, angle GIJ, or the other way around, angle JIG. Alright, example 2, let's practice identifying the pattern in these diagrams. Decide whether enough information is given to prove that the triangles are congruent using the side-angle-side congruence postulate, the side-angle-side pattern. So remember, you have to have two sides that are marked, and an angle, and the angle has to be between the two sides. That's what we're looking at. So we're looking at triangle PQT, and we're looking at triangle RQS, and we want to know if we have the patterns, the markings in the right place, in order to show, to decide that the triangles will be congruent. Sometimes it helps to cover up one of the triangles and just kind of look at one triangle at a time. So I see two sides, and I see an angle between the two marked sides. Think of it as touching the two sides with the markings. Same with this triangle on the right-hand side. I see two sides that are marked, and I see an angle that is touching those two marked sides. So this is a yes. We do have enough information. We do have the side-angle-side pattern. Let's take a look at part B. Here we have triangle NKJ. So there's N, there's K, there's J. I see two sides that are marked. Here's triangle LKM, LKM. Again, there are two sides that are marked. But I don't see any angles that are marked. Do you? No. But remember, we are allowed to add markings if we have vertical angles, because we've learned that vertical angles are always congruent. And notice that the vertical angles happen to be in such a place that they are between the two marked sides. So we do have a side-angle-side pattern. So once again, yes, we do have a side-angle-side pattern because vertical angles are congruent. And more importantly, not just at the vertical angles, but the vertical angles happen to be an included angle between the two marked sides. So before I go into this third part, one technique that you can use if you find it helpful, and let me kind of zoom in here a little bit, is to literally mark the SAS on the diagram. So let's say, for example, we're taking this left-handed triangle. Here's a tick mark, so that's a side. Here's another side that's marked, so there's a side. And then here's the angle, right, so there's the A. And then kind of read the letters. Doesn't matter which direction you go. There's an S, there's an A, there's an S. So that's a side angle side pattern. Or you could go down, you could go side, angle, side. If you have a triangle where the letters fall in a different pattern, then it would cause a different combination and it would not be the SAS pattern we're looking for. So that's a technique you can use. It's optional. If you find that helps you, check to see if we have a side angle side pattern or not. Alright, so now here's the third diagram in this example. Here we're taking a look at triangle WXY, WXY, that's the triangle on the left. Here's triangle ZXY, ZXY, that's the triangle on the right. You can see from the single tick mark that we have a single pair of marked sides. We have some marked angles. But where's the second pair of congruent sides? and that's our shared side right here. This is the reflexive property, right? So we know that we are allowed to mark a shared side, or in the previous example, a pair of vertical angles. Those come up. And so you might say, hey, we've got all the markings, but remember, you have to check to make sure of the pattern. So if you check the left-handed triangle, notice that we have a side angle side pattern. That looks good. That's what we want. We want a side angle side pattern where the angle's between the two marked sides. But if you check the right-handed triangle, you have an angle side pattern, which is not the pattern we're looking for. We want the angle in between the two sides, the side angle side, and this is the included angle down here at Y. But that's not the one that's marked. The one that's marked is a non-included angle out here at angle X. That's not the pattern we're looking for, is it? No, it's not. So we would have to say no. This angle here, I'll call this angle ZXY, is not an included angle. Alright, let's turn the page over and look at example 3. So here we now will have to create our own diagrams and add some markings. Example 3 says, state the third congruence that must be given to prove that these triangles are congruent using the indicated postulate or theorem. So they're giving us some information, two pairs of congruent parts, but you're always supposed to have three. So what we have to do is identify where would that third pair of congruent parts have to be located in order to have this particular pattern, side angle side, in this first case. Now what we have to do is we have to draw the diagram, and that way we can mark up the side. So here's triangle ABC. And then right next to that triangle, now they're not going in alphabetical order here, they're calling it triangle FED, so here's F, E, and D. So remember, the order of the letters matters. So if A is listed first, that has to pair up with F, so they are a pair of corresponding parts. B pairs up with E, and angle C pairs up with angle D. Alright, so now let's mark what they tell us. They say segment BC is congruent with segment ED. They're telling us segment AC is congruent with segment FD. So that's the given information, and what they're asking is, what third piece of information do I need? What third pair of parts must be congruent so that we can actually have this side angle side pattern? So we have two sides already. The only thing that's missing is the angle. So the question is, where should that angle be located? Remember, the angle must be between the two marked sides. Would that be at angle A? Would that be at angle B? Would that be at angle C? C is the one we want. If we can identify the third congruence as being here, then we would have the side angle side pattern. So the third congruence needed is that angle C must be congruent with angle D. So that's the idea. We're going to create our own diagram and then mark up the parts like so. I went ahead and drew these triangles in. Here in part B, let's mark up what we know. We know that segment AB is congruent with segment FE. And here we know segment AC is congruent with segment FD. Alright, so they are asking for the side, side, side pattern. Well, clearly the third pair of sides is segment BC and segment FD. So what we would need, the third congruence that we need, is to say that segment BC is congruent with segment ED. That's an E up there. And once we have that, then we can say that the triangles are congruent by the side-side-side pattern. Alright, so you try this last one. Draw your triangles, mark up the parts, and see if you can identify the part you need for the side angle side pattern. Here we're told that angle B is congruent with angle E, and that segment AB is congruent with segment FE. So we already have one side, we already have one angle. What we're missing is a second side. The question is, where does that side go? If we put, here, let me use my my marker technique. Here's the one side that's marked. If I were to put the second side here, well, then that means this is the included angle, but that's not the one that's marked, so this is not the side we want. If we put the second marker here to indicate the second side has to go here, then we do have the included angle marked in the right spot. So this is the side that we need. So we need to say that segment BC is congruent with segment ED, like that. Okay. So the third congruence that we need in this case, say segment BC is congruent with segment ED. Okay. So all of that is sort of topic one, identifying the side angle side pattern, or in some cases going back to the previous topic of the side pattern. And now we're transitioning to talk about proofs. Because remember, the goal of this is to show that two triangles are congruent, and it used to be that we had to show every pair of corresponding sides congruent and every pair of corresponding angles congruent. That would be 6 pairs of parts to show triangles are congruent, and what we're doing is we're proving we can do it with fewer combinations of parts. The side, or the side angle side pattern. So we have to look at this to determine which of those two patterns apply, and that's why it is so very important that we mark up the diagram as we go along. So we're going to be sort of bouncing back and forth between the diagram and the statements and what's given here, because if anything is named, we have to mark it, or if anything is marked, we have to name it. And we're looking for either 3 pairs of sides for the side pattern, or 2 pairs of sides and an angle if we want the side angle side pattern. How do we know which one it is? We'll have to look at where the markings show up on the diagram. Alright, here we have 2 given statements, and you can see that they are essentially the same concept as that we're talking about a midpoint. B is a midpoint of AE and B is a midpoint of CD. We could put both of them here on line 1, but if you just take a quick glance down the reason side, you see we're splitting them up here so that we'll have one on line 1 and the other on line 3. Okay? So, which one should I put here? You can see that if we're talking about a midpoint, if B is the midpoint of segment AE, well, what do midpoints do? Midpoints create 2 congruent segments. And these are the 2 congruent segments, and you can see they are named on statement 2. So that means we want the first of the given statements, because we're talking about how segment AE is going to be chopped into half, and we'll get 2 congruent halves here. So the first statement will be B is the midpoint of segment AE. So think of an if-then statement. If a point is a midpoint, then it creates 2 congruent segments. If you've named it, you've got to mark it, so put your tick marks on those. And if midpoint, then 2 congruent segments. This is your definition of a midpoint. You may remember that, and you could just write down definition of midpoint, and that would be okay. And even the definition, I've sort of condensed the if-then form. Notice the if part just says if midpoint. It would actually say if a point is a midpoint, then it divides a segment into two congruent segments. So you can see how we've abbreviated the if-then statement down to just the essential idea. Be careful you don't leave too much out, because then it will turn out to be incomplete. But this is how I'll be writing it. Here's our other piece of given information. B is the midpoint of segment CD. Alright, well, if B is the midpoint of segment CD, what does a midpoint do? It creates two congruent segments. So we know segment DB will be congruent to segment CB. If we've marked it, we have to name it. And so here we have segment DB is congruent with segment CB. Again, that's the same definition of a midpoint. Here it is printed out for us. If a point is a midpoint, then it divides a segment into two congruent segments. There it is. So we use the exact same definition of a midpoint twice because we had a midpoint in two locations. And so now you can see that we have a pair of sides. Here's a second pair of sides. So if we're looking for the pattern, we either need a third pair of sides to create a SSS pattern, or we need a pair of angles, and you can see some are listed right here on line 5, to create the side angle side pattern. Alright, so let's make sure that we've got these angles marked on the diagram. This is angle ABD, and this is angle EBC. Why are they congruent? Because those are vertical angles. So if angles are vertical, then they are congruent. That's the vertical angles congruence theorem. Alright, now, once you have 3 pairs of congruent parts, that's when you know the proof is done. That is to say, we have one more line where we then state the congruence theorem, or the congruence statement itself, and explain the pattern. Check to make sure that the angle is in the right spot. Is the angle between the two marked sides? It is. So this is your side, this is your side, and this is your marked angle. So notice it's side, angle, side, or the other way around, side, angle, side. So the angle is the included angle, it's in the right spot. And so we know these triangles are congruent by reason of the side, angle, side congruence postulate, which we abbreviate just as SAS. So I strongly recommend you mark your statements this way, where I have an S, and an A, so that you can count 1, 2, 3 parts. Because what I see a lot of students do is they will accidentally leave one out because they didn't bother to count, and they said, hey, I've got some parts, my triangles are congruent. And no, you cannot do that. You have to have 1, 2, 3 pairs of congruent parts in the right location before you can then declare the triangles are congruent. So on your quiz or test, I strongly recommend that you sort of count before you finish to make sure you have all the information we need. Okay, let's finish up with example 5. Here's our last one. Alright, so here we have AB is parallel to CD, and that's already marked. You see those arrows. We have AB is congruent. So that's interesting. We actually have 2 sets of information on the exact same segments. Keep in mind that just because it's parallel doesn't always guarantee it's also congruent, and vice versa. So these are 2 different ideas about parallel and congruency, but they happen to be exactly on the same pair of segments. So again, you notice that we have the given split up right here. So I'll take this first part of segment AB, parallel with segment CD for line 1. Now, anytime we are giving you something about parallel lines, we are always going to be talking about angles. Why? Because if parallel lines are cut by a transversal, then, and this is one of those angle pairs we've studied, then alternate interior angles are congruent. Right, so these are your parallel lines. If it helps, you can kind of extend them out. If parallel lines are cut by a transversal, then those alternate interior angles are congruent. All right. So, if you've marked them, you've got to name them, or if you name them, you have to mark them. Let's think of the if-then statement, and we have if parallel lines, then, and again, you have to be careful. You can't just say then angles are congruent. You have to classify them. What are they? They are alternate interior angles, and they will be congruent. Here on line 3 is the second piece of given information. So this is segment AB is congruent with segment CD. All right. Now let's count up what we have. This is a pair of congruent sides. This is a pair of congruent angles. What about line 1? Is that a pair of congruent sides? No. That's parallel sides. That doesn't count. If we want to show that triangles are congruent, we need congruent parts. The parallel lines just helped us find a pair of congruent angles. So what we need here is, and it's provided for us on statement 4, is another pair of parts, and it happens to be a pair of congruent sides. It's named, so you have to mark it. Segment CB is congruent to segment CB. That's the shared side. So that's your reflexive property of congruency. And then you have to count. Do I have 1, 2, 3 pairs of congruent parts? If yes, then that means we're essentially done with the proof. If no, that means go back to the diagram and find another pair that might be missing. But we do have all 3 the way it's been set up for us. So now we can declare the triangles are congruent. So triangle ABC. And remember, the order of the letters matters. So we have to name this second triangle correctly based off of the first triangle. So we have triangle A. So A corresponds with D. Then comes letter B. B is marked here, and that corresponds with this angle that's marked down here at C. And then lastly, on triangle ABC, C is the angle that is not marked, so that would correspond with angle B here. And our reason is the side angle side pattern. And it's side angle side because you want to take a look at one of your triangles and ask, is the marked angle between the 2 marked sides? And again, when we're looking at those sides, we're not looking at the parallel symbol, we're looking at the tick marks. So that's our included angle, so yes, we do have that side angle side pattern.